Okay, let's dive right into this explainer. Imagine, just for a second, a future where humanity finally builds a spacecraft powerful enough to cross billions of light years, a ship built to reach the very limits of space. What would we actually find out there? For centuries, we've looked up at the night sky and wondered, does the universe just go on forever, or is there a hidden boundary lurking beyond our reach? Today, we're exploring the ultimate cosmic mystery. What lies at the absolute edge of everything? Before we blast off, if you're enjoying these mind-bending future scenarios, make sure to like this video, share it with a friend, and subscribe to Last Human Era for more incredible journeys into the future. Let's get into it. So, does the universe actually have an edge? It's the core mystery we've pondered for generations. Think about it. If you kept traveling in that futuristic spaceship, would you eventually just hit a massive physical wall? Like, end of universe, turn back? Or is the idea of an edge just a giant illusion? To figure this out, we have to make a really crucial distinction between an actual physical boundary in space and the absolute limits of what we can simply see. 46 billion light years. Let's just sit with that number for a second. Because light takes time to travel, and the universe is roughly 13.8 billion years old, there's a hard physical limit to what our telescopes can detect. The radius of our observable universe stretches out a staggering 46 billion light years in every single direction from Earth. And yeah, if you're doing the math, that massive number accounts for the actual expansion of space over those 13.8 billion years. This brings us to a stark, mind-boggling contrast. On one hand, we have the observable universe, a finite bubble roughly 92 billion light years across. But the entire universe? That's a whole different ballgame. It could be infinitely larger, completely unmeasurable by us. Look, just because we can't see past our local bubble, thanks to the universal speed limit of light, absolutely doesn't mean there's nothing out there.
This boundary of our vision is what scientists call the cosmological horizon. It represents the absolute furthest distance light has traveled since the Big Bang. It's actually perfectly analogous to a sailor's horizon on the open ocean. Just like a sailor scanning the sea, our grasp of the cosmos is limited to the distance we can see. There is literally no reason why there can't be ancient galaxies, colossal black holes, and vast structures beyond this horizon. They're just invisible to us because not enough time has passed since the birth of the universe for their light to reach our eyes.
The shape of space. So to understand how an expanding universe could have no physical walls, we really need to look at the geometry of space itself.
To wrap our heads around this, physicists love using the classic balloon model of expanding space. Imagine the universe as the two-dimensional surface of a balloon, with little pieces of paper stuck to it representing clusters of galaxies. As you blow up the balloon, the surface area increases, and those galaxy clusters get further apart. But here is the kicker. The clusters aren't actually moving through space. Space itself is stretching between them. There's no center on the surface of a balloon, and there's definitely no edge. But what shape is the cosmos overall? Physicists generally outline three potential geometries. We've got positive curvature, which is like a sphere, negative curvature, shaped kind of like a saddle or a Pringle chip, or it could be completely flat, like an infinite piece of paper. And guess what? Current data, especially from the cosmic microwave background, strongly suggests our universe is flat, which means it likely stretches out infinitely in all directions, never curving back on itself.
Anomalies in the deep. Now this is where things get really, really weird.
As our theoretical explorers approach the edge of our vision, they'd start encountering strange anomalies where our physics just seem to break down. Check out this phenomenon called dark flow. NASA actually tracked the motion of distant galaxy clusters and found them mysteriously streaming at over 1 million miles per hour along a specific path towards the constellations Centaurus and Hydra. And this flow persists as far as 2.5 billion light years away. The truly mind-blowing part, the matter we can see in our visible universe cannot account for this gravitational pull. It strongly suggests that some massive, unseen structure completely outside our observable horizon is physically pulling on the matter inside it.
When we compare our standard physics model, which says the universe expands equally in all directions, against some startling new theories, things get even stranger. Researchers analyzing extremely distant quasars found that the fine structure constant, basically a magical number that dictates how subatomic particles interact, well, it seemed to change, depending on which direction they looked. If this data holds up, it means the laws of physics might actually break down or become directional at the edges of the universe. We call this the dipole universe model. It's almost like the universe has a north and south pole like a magnet, rather than expanding equally everywhere. Theories of the edge. Let's look at what the brightest minds think actually happens at the boundary.
First up, we have illusion and limit theories. A lot of physicists suggest the edge isn't a wall at all. It could literally just be the absolute limit of observable light, creating a bizarre time window where we just see the newborn universe. Or maybe space naturally folds in on itself at extreme distances, warping so intensely that normal forward movement is impossible. There are even theories suggesting that near the edge, time itself flows completely differently due to gravity, or that dark energy completely dominates, leaving nothing but a silent, cold, and entirely empty void.
Then we have the structure and multiverse theories. Space might simply be expanding faster than our ability to observe it, creating a horizon that's always running away from us. What if the laws of physics are entirely different beyond what we can see? Or, getting a bit more radical here, our universe could just be one bubble among many, literally bumping up against other universe bubbles with their own random physical laws. We might even be inside a much larger, totally undetectable structure, kind of like a single grain of sand on an immense cosmic beach, guided by hidden dark matter that we can't even register.
Holograms and extra dimensions. Okay, time to bend your mind a little bit with some advanced theoretical physics.
Stemming from string theory, we have the holographic principle. It proposes this absolutely wild idea. Our rich, vibrant, three-dimensional reality might actually just be a projection. Think of it like a security hologram on a credit card. The entire description of our 3D volume of space could be perfectly coded on a distant, two-dimensional boundary. The universe, exactly as you and I experience it right now, could simply be a holographic image projected from a far-off surface. And then there are extra-dimensional brain world models. This theory involves hidden dimensions, like a fifth dimension, separating our visible brain from a hidden brain by something called a bulk horizon, without a singularity. Look, the math is incredibly complex, but the core takeaway is pretty simple. The presence of these multidimensional bulk horizons could naturally explain why our spaceship could never see or interact with the true outer edges of reality. They are safely hidden away in dimensions we literally cannot access.
An infinite mystery. Let's bring all of this back down to Earth.
Ultimately, we have to reckon with the cosmological principle. This is a fundamental rule stating that on a large enough scale, the universe is homogeneous and isotropic. That's a fancy way of saying nowhere is special. Every place is essentially equivalent to every other place. If there were an actual physical edge or a boundary, it would make that edge a very special, unique place. And that totally contradicts the fundamental rules of our universe. An edge just doesn't fit the math of how our reality operates.
And this brings us to a profound final thought. The very atoms in your body were laid down in a tiny, infinitely dense point 13.8 billion years ago. We are literally made of the early universe. In the end, discovering the edge of the universe might not give humanity the simple answers we're looking for. Instead, it could reveal that reality is far larger, stranger, and more terrifying than we ever imagined. The closer humanity gets to the answer, the more unsettling the mystery becomes. And if these future possibilities fascinate you, don't forget to like, share, and subscribe, because every week we explore the most incredible futures humanity may face. So I have to ask, if you were given the chance to join that very first mission to the edge of the universe, would you go? Even if there was no guarantee you'd ever return? Let me know in the comments.